So we've evolved on this planet. We've evolved on this planet for a long time. These types of physiological interconnections show us this and demonstrate that we are biological systems that have been on this earth for billions of years. We can trace the anaerobic organisms in our intestines that make digestion possible back to those first single-celled organisms that lived on the earth 4 billion years ago. Those organisms took up inhabitants inside the intestines of organisms, partially because there weren't as many habitats left after a transition that occurred approximately 2 billion years ago, which was a transition from a methane-rich environment to an oxygen-rich environment. That transition happened because of blue-green algae in the ocean. Those blue-green algae in the ocean, just through their metabolic processes, changed the percentage of oxygen in the Earth's atmosphere to become a dominant gas in the atmosphere, and that caused a huge die-off event of all these anaerobic organisms that were thriving in the methane-rich atmosphere. So this is some of the story of how life has also transformed the chemical compound of the very atmosphere of the Earth, which has then begun to select for a different shakedown of species assemblages. So when we talk about speciation, one of the most amazing things about speciation is what's called adaptive radiation of speciation. The adaptive radiation of speciation is the process by which a species changes its physical characteristics as it modifies through the morphology of both recessive genes manifesting as dominant genes, but also the morphology of natural selection. So we both have genetic variation, natural selection variation, and we have cosmic rays, which will, through radiation, cause more rapid and aberrant forms of mutation to come about. So if an organism is in a high altitude landscape where there's a thin atmosphere, there's a lot more cosmic radiation that's affecting biological systems that are in high atmosphere landscapes, which means that there's an incredibly complex number of variables that influence evolution as far as species and adaptive radiation, the rapidity of it. One of the things that kind of begs the question when you get into this might be sort of lost on some folks, but the reason why I'm touching on this is because one of the things that people will ask is, well, how could this much diversity of life have spread all over the Earth's surface in so little time? And how do we have so much variation on the basic theme? Which is pretty astounding. We've got this basic theme, and now we've got an incredible amount of variation of life forms that have managed to optimize and make use of this basic theme.